Hi guys, and welcome to your next video lecture. This is the lecture for section 2.2 part B. It's going up today on Friday right before our 1 o'clock Zoom session, and the homework that will go with this section is going to be assigned today and will be due by 1 p.m. on Monday, as has been our practice so far. All right, without further ado, let's get to the notes. All right, let's see if that'll open up for us. There we go. Okay, excellent. So, as you recall, in the first part of these notes, excuse me, we discussed how we can use sets and operations of sets to help us sort of talk about some basic things that we do in mathematics. And we talked about how understanding those sets helps us to have a basic understanding of whole numbers, things like the difference between a cardinal number, which is the quantity that we're discussing, and the numeral, which is the symbol that we use to represent that quantity. And then we talked about how there's also a way of using numbers just for identification, wherein that set of numbers itself doesn't hold a value, which is why we discussed the whole concept of using numeral sequences, for example, for our social security numbers or for our phone numbers. These things don't have value. That sequence of numbers doesn't have a quantity it represents, but it does represent an identification. So we talked about the different usage. Now we're going to talk about how understanding the usage of numerals or the quantities. Please excuse me. Not sure why that's happening. Okay, but we discussed how the quantity of numbers. Now we're going to move on to systems that were created to have that very distinction, to be able to discuss quantities in different ways and have their own numerals or symbols to represent these quantities. And you might ask yourself, why are we talking about different numerical systems? Well, two reasons. One, it gives you a different way or angle to look in the universe at how systems work, and gives you a deeper understanding of that. But it also allows you to get a sense of what it's like for your students in your classroom, particularly if we're talking about brand new students, like kindergartners or first graders that have never really worked with our own numerical system. And you can get a feeling for what it's like for them when you're teaching them things like place value, which is going to come into play with these numerical systems we're going to discuss. And you're teaching them the concepts of things like ones and tens and hundreds. And sorry for my angle here, I'm just plugging in the laptop. So that it's going to give you a whole new sense of that as well. Plus, I know you guys aren't going to agree with me, but it is kind of fun. All right, so let's move on. There are different numeration systems, and we're only going to look at a very, very few, okay? But the official definition of a numeration system or a numerical system is the definition. So let's look at the definition of what we're talking about, okay? The definition is that a numerical system or a numeration system has symbols, or as we call cardinal numbers, right? Or sometimes we call them numerals. Okay, this numerals is the term that I'm going to use the most to distinguish when I'm talking about the symbol versus the quantity, okay? And differential numeration systems has symbols or numerals that we will be using that have been developed to represent the numbers, which is the word that we're going to use to mean quantity. Okay? So a different number system has different symbols that represent quantities, is another way of putting that definition, okay? And we're going to start with a simple one. We're going to start with the tally system, which you guys are all familiar with. And in fact, when you teach elementary school, this is usually where we start. We teach the tally system as a way of helping to bridge. My deepest apology, guys. I'm not really sure why I'm yawning so much. I had tons of sleep. So I don't know what's going on. But we teach the tally system as a way to bridge into place value, and have them understand what that means, and also to bridge into the discussion of tens and ones and hundreds. Okay, so the tally numeration system, here is what it is. It is composed of single strokes, one for each object that's being counted. You can think of it as two different sets. We have the set of the objects that are being counted, right? And we have the set of the tallies that are being used to represent each of the objects. You'll notice that these two sets have one-to-one correspondence. So they are indeed equivalent sets, right? Which is why they are useful. They are useful because this is a pretty simple concept, one that is easy for everyone to understand. There is, however, a disadvantage. The larger the numbers that we are talking about require a lot of symbols. Therefore, large numbers are difficult to read, okay? Because the symbols or the numerals for large numbers would require a lot of effort. And remember, this is a key point, okay, right here, in what makes a numerical system that has been adopted and is now used all over the world, what makes it that way. And that is the efficiency of how quickly you can read large numbers and use them in operations. Obviously, we can use any system like the tally system to accomplish that, to create symbols that then represent the quantities that we're talking about, and those symbols we could adopt as our numerals. However, if it's very bulky like the tally system is, it makes it not really one we want to work with if we want to do operations like addition and subtraction, multiplication, and division. Because you've got these very bulky systems that are very large, these numerals that are very big that we have to move around. So that is the disadvantage of the tally system. Now, we did improve it to some degree, and that's kind of where it stopped, which is why it's not been the worldwide adopted system to use for numbers, right? But we did improve it by creating this concept here, and that is that the fifth tally mark is placed across every 4 to make groups. This, however, is the reason why it's useful as an intro activity or as a way of bridging the gap when you are teaching place value, because it does introduce this idea of grouping things together in quantities. Like we do in our system, we group them in tens. That's why we have ones, and then we have tens, and then we have hundreds, and then we have thousands, because we keep grouping them in tens, okay? And this concept of grouping is very important because the other numerical systems that you're going to see, that's what they did too, to help improve the quality of the number system they were using. They found ways of grouping things, creating in essence their own place value, so that calculation and things like that would be easier, okay? And you all are familiar how we group the tally system. We group it in groups of 5, right? So here, for example, it would be easy for us to look and say, instead of having to count each individual tally, we can count and we can say, this is 5, that is another 5, so that's 10. This is 5, 10, 15, and then 1 is 16. So it makes it easier for some simple calculation. It would still get very cumbersome if we're talking about multiplication. But for simple addition calculation, grouping it has made it easier, all right? So now the first system that we're going to look at is the Egyptian numerical system or numeration system, okay? Little background information. It was developed in 3400 BC, so it's quite ancient, okay? They also group by tens, which is very similar to what we use, okay? But they grouped them similarly in the system they used was a lot like the Roman numeral system, which we will actually be looking at a little bit later on, okay? And they had what's called an additive system, meaning that the values of the symbols add together. This is the case for the Roman numeral system as well, okay? So here is an example of how their system worked. This is my hand at drawing their symbols. However, if you look at figure 2.14 at the bottom of page 60, you're going to get a better visual of the symbols, but this is my hand at it. So what we have here is the one, what we would call a tally mark, that is a 1. What looks like a sort of a sloppy N for us, that is their 10. What looks like a question mark to us, that's their hundreds. This here, to me, it looks kind of like a boat on a triangle. That is their thousands, okay? This looks sort of like a kidney bean. That is their 10,000s. And this looks kind of like a fish to me, and that's their 100,000s. But if you look in your textbook at the bottom of page 60, they will tell you what each of the names of these things are. So this, for example, here, what we call our bad 10, badly made N, is called the heel bone, okay? This was called the scroll. This here was called the lotus flower, okay? This was the pointing finger. And this was a fish, so we were on the money on that one. That is called fish. And they have one more, which looks like a little stick figure man, and that one was called the astonished man, and that represented 1,000,000, but I didn't think we had to go that far, okay? So, for example, to write the number 321, they would write it this way, okay? Now, what are some of the advantages? And so you can see here they had 3 hundreds, right? 3 scrolls, 2 10s for 20, and then a 1. Now, advantages of this system. Well, it obviously requires fewer symbols to represent large numbers than the tally mark, because if we had done 321 in tallies, it would be really big and very cumbersome. So they have less, so that was an advantage. A disadvantage is that it's still big enough where calculating things or performing computation becomes cumbersome. And here's an example of it, okay? So if we look at this example here, they gave us the numbers 764 and asked us to add it to 598, okay? Here is 764 using the Egyptian numeral system, plus here's 598. And then you'd have to add, and obviously there's carrying that or conversion that's going to occur because you add your hundreds and you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right there, you have to convert that into 1,000, right? So that's your 1,000. And then you still have the leftover hundreds, okay? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's your 1,000. We have the leftover hundreds. Okay. And then we have our tens that we have to count. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. That turns into 100, right? And then we have another 10, 20, 30, 40, 50. So we hold on to those. There they are. Okay. And then you have your ones, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That turns into a 10, and then you have your leftover ones. Okay, so our 10 tens, which we have here in yellow. So here we got these plus these became this guy. Okay, then we had our leftover hundreds, but we had 10 tens, which became 100. So really, here are these 3 together right here. Okay, then we had our leftover tens, which were these 5 right here, but we had one more that came out of the ones, so that's right here. And then our leftover ones to get our answer. And our answer is 1,362. Okay, and there's your answer right here. Now, calculation is possible, but you can see that it is cumbersome. So it's one of the reasons why that number system sort of died out, right? Let's move on to the Roman numeral system, okay? Now, this system, as far as its use for calculation and everyday mathematics, has died out, but it's not completely gone. We still like to use it when we want to number things in a fancy way, right? So we still kind of have to have some familiarity with it. I mean, at least, for example, all the Super Bowls are named using Roman numeral systems, right? Okay, so the Roman numeral system began at approximately between 500 and 100 BC. So it was 500 BC to about 100 CE. So it had a nice long span of usage. And it also groups things by tens, like we did. Okay. And it was also an additive system, like we saw with the Egyptian system. Okay. Here are its basic systems. The I, capital I, is a 1. Then you have the capital V, which is a group of 5, capital X, which is a group of 10. Then you have L for 50, C for 100. By the way, that's where the whole concept of C note comes from. Okay. D for 500, M for 1,000, and it goes on beyond that. All right. So, and again, if you want to look at a good example of these systems, go to table 2.2 and 2.3 on page 61, and you're going to see a nice table that breaks down these Roman numerical systems for you. Okay. However, one new thing that they did is they introduced the subtractive principle. Okay. Meaning that in the numerical system of the Romans, let me slide that up for you here. Okay. You can have, if you put symbols in front, you're adding. If you put them behind, you're subtracting. So for example, here for the number 4, we start with the symbol for 5, and we put the symbol for 1 behind it, meaning we're going to subtract 1, and that gives us 4, okay? However, if we put it in front of it, okay, like, and I'm going to try to highlight this for you. So here we have an example of the subtraction, okay? Here we have the additive concept, where you take, still, you want to do the number 6, you start with the symbol for 5, you put the symbol for 1 in front of it. This means add them together and you get a 6. Now, doing this, okay, this subtractive principle and addition principle, using that to determine different numerals, meant that you introduced in the Roman numeral system this idea of a positional principle, or what we later termed place value, meaning that the position of the symbol determined the value it was representing. Okay, that is something that we then later apply in place value, and it kind of got its roots here in the Roman numeral system by them introducing this concept of the subtractive and additive principles. Now, up until now, the systems we discussed had the additive principle sort of built in. The Romans really sort of expanded on it and said, okay, well, if you can have the additive, you could do the subtractive. And by doing this, all of a sudden now, the position of the symbols determine the quantity they represent. And that is a very important leap forward in numerical systems, okay? Now, remember, important to know that the position is determined by left to right. And this is important because in our numeral system that we now use, left to right matters as well when we're discussing mathematics, okay? All right, let's move on to a multiplicative system. It was also introduced here in the Roman numeral system. They also introduced what was called a multiplicative system, okay? Meaning that they came up with this symbol. Here's the definition. You put a bar over a numeral, and it would mean to take that numeral and multiply it by 1,000. So if you took the numeral V for 5, and we're going to look at these examples here, okay? If you took the numeral V for 5, and then you put the bar over it, now you were saying take 5 multiplied by 1,000. So really now this symbol represented the quantity of 1,000. If you took the symbol for 10, which is X, and put 1 in front of it using the additive principle to create the number 11, and then the bar over it to say times 1,000, now this new symbol meant 11,000. So it was a pretty sophisticated system. However, it was still too cumbersome to do advanced mathematical computation, which is why it still did not stay in use for very, very long. Now, let's look at an even more ancient system than even the one we discussed before, although there is some overlap with this system and the Egyptian system as far as the time when they were being practiced. And that is the Babylonian numerical system, okay? Their numerical system was developed sometime between 3000 and 2000 BCE, okay? Now, it only used two numerals, two basic symbols, okay? There was a symbol for 1 and a symbol for 10. One of the big differences here is that their system was based on the number 60. The systems we've discussed till now, and including ours today, was based on 10. That's how we do our groupings. The tally system's based on 5, which is just a factor of 10. That's how they do their groupings. The Egyptian system was based on 10. That's how they did their groupings and changing of symbols. The Roman system was based on 10. Again, there was some breakdowns for 5, but that's just a factor of 10. So their systems were still based on 10. Here, in this system, this is the first system we're going to introduce that did not do that. They based it on 60. Okay, so they did that up to the number 54. Okay, this is sort of interesting. Up to the number 54, their system was additive, and they also had positional, meaning that where the number was located did determine its value, okay? So based on the building blocks of place value from the Roman numeral system, which they never really determined that they were having place value, but they did determine that position mattered. Then the Babylonians did have a system in their case that did have place value, and that did matter, okay? So their place value, and that's what we're gonna look at here, their symbols were this. The triangle, I'm going to try to highlight it here. This is 1. And this little sort of mouse symbol, this was 10. Okay, so this is 1, this was 10. However, depending on where you placed it, it was either 1 by itself, or if you moved it to the right, and that's why you'll see here for the number 60, that there's space here. If you moved it to the right, then that became that symbol times 60. So now, instead of this being 1, it's equal to 60. However, if you see that we move it to the left, then it's just 1. Okay? So to write the number 37, this is how we write it. If you look up here, this is our way of writing the 37, right? But in the Babylonian system of writing it, you would take your 10s, here they are, right? So 10, 20, 30, and then you would have your 7. Now, it is important that, I think, if I'm not mistaken, they would write it in the other order, because you want your 1s to have the value of 1 and not times 60. Okay? So here it is, there's 7, and this would be 37. So here, okay, in order to write 60 plus 42, you'll notice that we have the empty space here, meaning that this 1 no longer represents 1, it represents 60. Then we have the 40 and 2, okay? And now I know that I'm doing 60 plus 42, which gives me the answer of 102. Don't break your heads over this too much. You will have some homework on it, but we're going to keep it to the basics because, obviously we're not very familiar with the system, but it is useful as far as how they introduced place value. Where the ones were determines it. Now, if I'm not mistaken, and feel free to correct me, but based on what I understand about the Babylonian system, if the 1 was moved over, it was times 60, but if the 1s are after 10s, then it's not times 60. That's what I have figured out thus far with my experience with the Babylonian system. Now we're going to move on to the Mayan. And out of the number systems we're going to look at, the Mayan is kind of my favorite. It's a little trippy, but I think it's also kind of ingenious, so I do enjoy it quite a bit. okay? So the Mayan numerical system, okay, was developed between 300 and 900 CE. So it was a little bit contemporaneous or immediately after the usage of the Roman numeral system was no longer sort of in use in the Western world. This Mayan system was being developed. Now, a couple of things to notice. Their system is vertical, okay? Meaning they don't do their place values from left to right. They do it from bottom to top, okay? So that's the first thing to remember. Also, they are the ones credited with introducing the concept of zero. You will note that the systems we looked at prior to this one did not have the concept of zero. They had quantities that we used, but they didn't have the concept of no quantity. However, in the Mayan system, they did introduce the idea that there is such a thing as not a quantity. And zero is very important because our system takes full advantage of zeros, okay? And they also really minimized their symbology because they brought it down to only 3 basic elementary symbols or numerals, okay? And here they are. Here are our 3 basic ones. We have the dot that stands for 1, the horizontal line, which stands for 5, and the what looks like a shell. I think it's meant to be a seashell that represents 0. Okay. Now remember that we read numbers from bottom to top. That's why you've got this little note right here. So for example, if I wanted to write the number 6, I would write it like this. 5 and 1 is 6. The number 11 is 5 and 5 is 10 and 1 is 11. Okay. And we're always reading them from bottom to top. Now, that's not the only bottom to top though. Here's the next thing you have to remember. You can see the other examples here for 8 or 19 or 20. Now, it is important that you notice 20 because 20, okay, requires, that is what their place value was determined by. It was determined by the numbers 18 and 20. You're going to see in a minute what I mean. But also important to note that for 20, okay, what they used is 0, and moving up into the place value, they put 1 in the place value of where 20 is. And that is why I'm saying now, let's look at this number system a little bit more closely. Here, I want you to focus on this first, okay? Because this is kind of how they do their place value system. By all means, they did not use these grid lines like I'm using them, okay? But I find that using these grid lines makes it a little easier to understand. So in the Mayan number system, okay, the bottom layer is your ones. And this is where you would put your combinations of dots and lines up to 19, okay? However, if you wanted to represent the number 20, you would put a dot in the second line, meaning that you have 2 10s or 20. And because you wanted to have that placeholder of 0, you would put the 0 symbol in the 1's place, which is why you would end up with the symbol that you see up here for 20, okay, right here in the red. You see it, that you would write it like that. You would put in the shell and the dot, and that represents 20 because you have 1 20 that is 20 by virtue of placement, and then you have a 0 accounting for the fact that you no longer have any 1s. Okay? Now, the next place value up, you take 18 times 20, and whatever you place here gets multiplied by that. Now, 18 times 20 is 360. So basically, any symbol you put in this third box right here would get multiplied times 360 for its actual value. And then if you move up to the next level, it would be 18 times 20 squared, which comes out to 418. So this would be 18, okay? It would be 418 times whatever you put in it. And in this top square here, they had 18 times 20 cubed, and so on and so on and so on and so on, building up. Now this, I just went this far because numbers that we're going to deal with for the purposes of this lesson are never going to go beyond this. Okay, so let's look at some examples so that you can see what we mean. But keep this little chart near you as you get used to it, because it does help to sort of clarify how to use the system. Okay, so let's look at this example here. This example, by the way, in case you're interested, comes to you from figure 211 on page 64 of your textbook. All right, but let's say that we are given this Mayan numeral right here, okay? Looking at it from where it is, this is the ones place. So I will count this as 5, 10, 15, 16, 17, 18. So I have 18 here. And because it's in the ones place, it's saying 18 times 1. So that is 18. And that's just this level right here. Okay? Then in the next place, which is the 20s place, I have 5. This is the 20s place. So that means that I have to really do 5 times 20. 5 times 20 is 100, which basically means that this numerical system right here is just representing 100. So this entire symbol is 100 plus 18, or basically this is the numerical symbol in the Mayan system for the number 118. Okay, everybody follow? Let's do the next one. Okay, you get this numerical system and you break it into the place values. I find it's very helpful to break it into the place values using this little grid because it's easier for me to keep track of the numerical system. If I had been a Mayan, I probably wouldn't need this, but since I'm not, this is a little cheat sheet that I use to help me, okay? So in the ones place, I'm being given this symbol. I know this symbol is a symbol for 6, which really means that I'm doing 6 times 1, or I have 6 in my ones place, okay? In the 20s place, because remember the second place up is always times 20, I have that same 6, so that means I'm really thinking 6 times 20. So in the second place, or in the 20s place, I have 120, okay? In the third place, which is the 360s place, or the 18 times 20 to the first power, however you want to think about it, I find it's easier to think about it as 360. They gave me a 1 symbol, so that means that I'm doing 1 times 360, so the amount that's in my 360s place is 360. So this total number here is 360 plus 120 plus 6, or the representation for the number 486, or the quantity rather, 486. Okay? Let's do one more for good measure. So you can see here, they gave me, this is the symbol I'm looking at, okay? And remember that I have to read it from bottom to top. So I start down here in the ones place. The ones place has 5, 10, and 3, so that's 13. That's 13 times 1. So in my ones place, I have 13. In my 20s place, they gave me the symbol for 0. So that's 0 times 20, that's 0, okay? In my 360s place, they gave me the symbol for 5. So that means I have to do 5 times 360, which is 1800. Okay, so if I add those together, that's 1813, and that is the quantity that this numeral in the Mayan system represents. I hope that that made some sense to you, because I know the homework is going to ask you to do some of this kind of calculation. All right. A good tool to also to help you understand these numerical systems is table 2.4. Okay. So please go and look at it. Table 2.4 is found, I believe, on page 65, but I'm checking that for you right now. It's at the bottom of page 64. Okay. So it's a good thing to look at. It sort of helps to establish some of the basic concepts that we've discussed in the systems that we've talked about today. Your homework for section 2.2b is already up on the taskbar. It is available to you there. It is, I'm going to tell you what it is as well, just to make sure there's no confusion, but it's already on the taskbar, and it's on page 65. It's numbers 7 through 14. Okay, so 7 through 14 on page 65 is the homework assignment for this lecture, which was a lecture 2.2 part B on numeration systems. And this is going to be up, and it will be today's lecture and today's homework assignment. It will all be due by 1 p.m. on Monday. And I will see you in a little while at our live class. Bye-bye.